Hi, I'm Kevin Drinkall.
Hi, and I'm Michel Nicolai, and we welcome you to Zyzone Networks podcast.
We've been in the network industry for over 15 years, and in these podcasts we want to try and untangle the world of networking, debunk some of those myths, explain some real-world examples along the way, to help you make better choices about selecting the right tech, product, and even help you guys build faster, more reliable, scalable networks, or just to keep your kids happy at home. Well, welcome back to another round of our podcast, and in today's podcast we're going to talk around improving wireless and understanding a little bit about the environment and how it is, and see if we can help improve with some tips and tricks around what to look for when deploying Wi-Fi. Often there is no one size fits all Wi-Fi, right? It's very, very complicated. The environment is often very different, and we need to look at things like the obstructions that are in the path of Wi-Fi. And in an absolutely ideal world, there would be nothing between the wireless access point and the device connecting. And, this would be perfect connectivity, right? There's nothing in the line of sight.
Yeah, but Kevin, that's not in real life, yeah. In reality, we have to deal with objects in between, yeah, that stand in the way of a proper Wi-Fi connection. So even the frequency is important in this matter, because it all has an influence on the signal strength, and especially if you're dealing with objects like glass or walls or floors, they all have an effect on your Wi-Fi. So there are many factors that depend on good Wi-Fi. So I think we can put them under three topics. One of them is obstructions. So what are the things in between your access point and your device? Those kind of devices. Of course, the frequency is important. How good your signal is when you're receiving it. And of course, the capacity is very important. Are we connecting with a single device or with multiple devices to an access point? So that's all need to be in this solution. So let's start with obstructions.
Yeah, absolutely. I think so. Something we just want to say before we carry on, though, we're really focusing on indoor Wi-Fi, right? So outside obstructions, there of course are tree leaves and other things, but because predominantly we're dealing with indoor Wi-Fi, then we need to talk about these kind of these obstructions. So walls are a big factor in what happens in Wi-Fi, and like I said before, there is no one fits all solution, because not every building is the same and often has different construction materials. For example, a lot of the walls are made out of concrete or stone or studded, or even some newer buildings to keep insulation in and now have some kind of foil inside the internal walls as well. And this makes for very different results in Wi-Fi. And you need to remember that Wi-Fi itself, when it's passing through walls, the signal is lost as the energy is absorbed by the materials. So, the thicker the wall, the more challenging it is for Wi-Fi to pass through. So you may not get the desired coverage or the desired throughput, and it could be more complicated, especially for buildings that are older, that have thicker walls. And in fact, in some cases, I think, you should think about how you're going to physically wire an access point in between those spaces rather than trying to pass signal through them. And that all really depends on how your environment is. And that's why whenever you ask, for guidance on Wi-Fi from somebody, they really struggle to give you guidance without understanding the environment it's in as well. Because, when someone says, how many access points do I need? It's not quite as simple as that, because these factors, like Michelle mentioned, are all in play, and every single site is different. From a house to a building to a multi-story building, it's all different types of environments that you need to consider. On the counter argument of that, though, is that you could use these to your advantage. So walls can be used to an advantage. So you can use it to contain wireless within an area. So don't always think as Wi-Fi or these obstructions as a bad thing. You can use them as a benefit as well. So there are good pros and cons for having thick walls, for example, because you can actually contain the Wi-Fi in one area and keep the signal extremely good without any loss to other devices outside of that, and we'll cover that a little bit further as we go along.
You talk about walls. How about glass?
Yeah, so glass is another one. In an ideal world, as we suggested at the beginning, you might have a clear line of sight to the access point, but if you've got glass in the middle of it, will have a dramatic effect on Wi-Fi signal. So just like when you shine light through glass, it actually disperses in different directions, and it's the same with Wi-Fi signal when it passes through glass as well. So if you have a building which is completely covered in glass, glass rooms, then really you should consider a different method of deploying, as in you might not be able to put one access point in the middle and serve all these rooms that are using these glass walls. You might have to consider actually putting access points inside the rooms as well to get the coverage, rather than having all the issues with the refraction of the wireless signal itself. So again, this can be challenging environment, just as walls can be as well.
We talked about obstructions like wall types, concrete walls, and even glass. But maybe we should give some top level information on the differences of the frequencies and how they work in such environments.
Yeah, so in Wi-Fi we have three predominant frequencies that we can use, right? So we have 2.4 gigahertz, 5 gigahertz, and 6 gigahertz, and they all kind of have their pros and cons in which one's best, right? So, in the early days, 2.4 was definitely the prominent and the de facto of Wi-Fi, and the reason for that was that 2.4 gigahertz has the furthest reach because it's a lower frequency. So it means that when it passes through objects, it actually can pass through them much easier. So the coverage is much better. But the trade-off is that there's a lot of congestion in that frequency. There's a lot of interference from both Wi-Fi and non-Wi-Fi devices that can create a great deal of issues. So really, yes, you can transmit much further, but you have the restriction of lower bandwidth and obviously congestion and interference from other devices as well. So other devices like Bluetooth are also operating in 2.4 gigahertz as well, and baby monitors and other objects as well. So, and they don't necessarily play very well with Wi-Fi.
Yeah, but 2.4 is still interesting, yeah, because as you mentioned, the coverage, and as soon as you get the client into your Wi-Fi, the coverage is really important. Even it's only 2.4, then you grab the client and then you really can manage that client up to the better frequencies. So it's good to remember is that the lower the frequency, that means the larger or the further coverage. Yeah, maybe you can remember when a car drives through your street with a big bass. Yeah, it's a very low frequency. You can hear it everywhere. But yeah, if you listen to classical music, yeah, it's much higher tones, and those will not travel as a long distance as the bass. So that's something to remember on those frequencies.
Yeah, exactly. So, we're talking about, I know Wi-Fi itself, but it is a frequency, right? And just like you mentioned, sound is the same, right? The low deep tone is the low or the lower number, right? The lower in the frequency, so therefore it can travel much further. And then like you say, the higher pitch is much more difficult because it's a higher frequency. But the trade off of a lower bandwidth from something like 2.4 gigahertz is that, like we said before, there is much more interference and there is less frequency available to share. And whilst it might pass through walls, a much better throughput through that than, say, 5 gigahertz, we do need to look at the 5 gigahertz itself because along came more issues around capacity, right? So whilst you can have this lower throughput further distances, reality is it's not really going to work in modern day devices.
Yeah, and capacity is the number three. Yeah, that's really important. As you said, 2.4 is not good enough to have a good high density deployment. So we need to move up into a higher frequency, don't you think?
Absolutely, yeah. So I mean, and now we have the 6 gigahertz as well, and we'll talk a little bit about these frequencies and how they're broken down and how they're used a little bit further. But the important factor is that if you need coverage, then you would need to be lower. But if you need to find a balance, then 5 gigahertz was the way to move into capacity, higher throughputs, and it didn't have that bad a coverage, and it still today is pretty much the de facto in how we work. And obviously now we've introduced with the latest standard of Wi-Fi, we have the 6 gigahertz band, and again, it's a higher frequency, so it doesn't travel as far. But again, it has the capacity. So I guess we should talk about the placement of a wireless access point and why that's so important. So when it really comes down to the placement of an access point, it's down to the actual antenna design, and this is often designed like a semicircle. So when you put it on the ceiling, it's designed to have this optimum coverage beneath it that allows it to give that performance. And we see a lot of the time where people put the access point on the side, fit it against the wall. And actually, that's counterproductive for a lot of access points because they can't really do the coverage. They start to push the signal into the ceiling and into the floor and not out into the room as you would do if you did a ceiling mount. Of course, unless you have a Zeiss optimized or smart antenna, then this really becomes a bit of a problem for performance.
Yeah, so it's really the positioning of the AP as Kevin mentioning, because what you see often is that people receive routers from their ISP and they put it on in places where you definitely never want to start your Wi-Fi, because that's not the optimum environment where you want to have the Wi-Fi. You want the Wi-Fi maybe in the living room, yeah, or in the middle of the office. But so make sure you have the IP on the right position.
Yeah, I think for routers, going back to that, it's a similar sort of position where, if you put them on their side or on the, flat, they have an optimum condition as well, right? They're not designed to be on the ceiling. So again, if you're looking at these types of products, then positioning them correctly and understanding their optimum condition can also improve their coverage and in turn your performance that you'll get from Wi-Fi. But like I say, most generic access points are all optimized to sit on the ceiling and all have this kind of approach, like I said, with this semicircle underneath them to give that coverage.
But maybe we should talk a little bit more about frequencies, the let's say the Wi-Fi highway that we are using with our devices.
Yeah, so we touched a little bit about the frequency, right? But we need to really consider about how that's broken down. And the Wi-Fi itself and the frequency is broken down into channels. So you can think of this as breaking it down into roads, right? And regardless of whether it's 2.4, 5 gigahertz or 6 gigahertz, they're all broken down into these roads. Okay, and you can think about it as a highway, or because I'm a Brit, we can call it a motorway. You have this busy motorway and you have these busy roads, you have peak times and you have off-peak times. So understanding who is using those roads or the channels in the Wi-Fi helps you make a judgment about how you're going to select a channel and even, understand the kind of dynamics that's happening in your environment. And like we said at the beginning, not every single environment is the same. So you really need to study or have a look about what's happening in your environment and whether you can even control some of the channels that are in use.
Yeah, and what will be really helpful, for instance, within Nebula, we can visualize what the channel utilization is on each channel, on allowing the AP to make adjustments so that yeah you free up the roads a little bit more, so to that the traffic passes better. Yeah, that's really key for that. Another important factor, of course, is when two devices, access points maybe, are broadcasting on the same wireless channel, because that can also have a big impact on your connectivity. If that happens, we talk about co-channel interference. Yeah, so both of the devices, wireless devices, it can be a non-wireless device as well, using the same frequency, but then they are not helping each other. No, they creating all kinds of collisions. Yeah, it's like on a motorway that people come together and they're creating an accident. And when the accident happens, it takes more time. Traffic jams come in. And when the traffic jam comes in, you're late at work. So there are all things happening, and it's the same on Wi-Fi. So to fix this or to help you to avoid this co-channel interference, you might use our smart antenna technology to reduce this co-channel interference on your network. If you want to know more about this co-channel interference and smart antenna technology, I would like to point out to our other Wi-Fi podcast where we go much deeper in this kind of solution.
So we covered, the Wi-Fi highway. We covered a little bit about the placement of access points and even the frequency. But one of the things that we need to really talk about is how to measure Wi-Fi itself. So you can't see it, right? So you need to look at how you can measure the wireless signal itself. So the first thing to know is that Wi-Fi 4, Wi-Fi 5, Wi-Fi 6, or even Wi-Fi 7, the wireless standards themselves, they're all measured the same way. And they're measured using a metric called dBm, so decibels relative to milliwatts. And this will always be shown as a negative number. We also use another thing called the Received Signal Strength Indicator, the RSSI, to gain an understanding of what the connectivity is like from the access point to the connected device, like the mobile phone device. And like I said, the numbers are displayed in negative, so a minus 30 would be the start point, and this typically runs between minus 30 and minus 90.
So that means that with minus 30, you're almost sitting on your access point, and with minus 90, you are, get disconnected.
Yeah, absolutely. Yeah, you're practically, touching the access point at minus 30, right? And that's deemed a perfect connection, right? And if you spot a signal where you are at minus 90, like you say, then that's kind of deemed the end of the line, right? It's so at the edge that you wouldn't be able to connect at all. Of course, unless you're using a Zeisel smart antenna, right, where there are exceptions and we can operate much higher than that. An excellent condition or network condition is actually considered to be like minus 50 dBm. And if you see something like minus 60 dBm, then you're likely to have a good enough stream to handle voice calls and anything else that's typically happening in a network. So within Nebula, our cloud platform, you can also see the connected devices, you can see their signal strength, and you can understand pretty much this element of the connectivity. So you can measure and check which devices have poor connectivity and which have good connectivity right within the platform itself. Of course, if you want to handle it from the client side, and you want to see how the signal is from the client side itself, there are plenty of tools out there, and there are an abundance of them, but one or a couple that I like to use myself is MetaGeek. It's called InSSID, so Insider, which is a play on the Wi-Fi SSID. Or Wi-Fi Commander is a nice little tool that just kind of shows you the usage and the channels and everything from the computer side.
Yeah, but I think people to remember that when devices are connecting at the edge, so you see them over minus 70 till minus 90, it can be a great impact on the performance, not only the device itself, but also the other devices that are connecting to the same AP. Even if the AP has more SSIDs, it has also impact on those SSIDs as well. Yeah, so a good option there if you want to make sure that your low performing devices have not a major impact on your network. Maybe you should put them on the 2.4, yeah, like IoT devices, and then make room for your more higher performance devices and put them on the much better 5 or even 6 gigahertz if you're lucky enough to have the Wi-Fi 6E standard.
Yeah, absolutely. Yeah. Okay, I think that's a lot of information for people to digest, and I think it's probably time to have a bit of a roundup. So, from my point of view, I think if you are doing Wi-Fi and you've had problems with Wi-Fi, you should do the basic checks, right? You need to make sure you've got the connectivity to the Wi-Fi, the DHCP, the DNS, and even the internet itself, which sounds obvious, but it's one of the most common things that we kind of see as a vendor. You should check the Wi-Fi signal, and obviously we've covered how to measure that. So it's a good idea to try and keep things around the minus 50, 60, as that's considered good. And you also should select the most appropriate channel for your location, your devices, and even your performance requirements as well.
Yeah, and it's also really important to check your environment around, what kind of walls or glass, what type of floor there is in your environment, because they play a big role in your wireless connectivity. And to check this kind of connectivity, we have some great tools available in the Nebula platform. We have the Wi-Fi 8 to check on your DHCP and on your DNS connectivity. But we have an even far more advanced tool with AI in there. It's called Wi-Fi Health. And with Wi-Fi Health, we can check on what kind of AP in your environment has bad connections, and you can act on that to search where the problem is. And we can even give you a good overview of all the clients that are connecting to your Wi-Fi network and how the clients are being seen through the eye of the access point, how they are connecting to the AP. So that gives you a very detailed information of doing a search when a problem occurs in the Wi-Fi environment as you has rolled out.
So some really good tools there, and some, I think, pretty good advice, I think, to consider. The topic of Wi-Fi is massive, so we could spend all week talking about different elements of it. So I think to get the bits that we've got inside of this, I think that's very, very good. So I think hopefully you guys have learned some stuff there, and you can go away and utilize that in your environment. And thank you very much for listening.
And don't forget to subscribe to our podcast, and hopefully to see you soon on the next podcast.
Thank you.